Welcome to part one of the chapter one test review. So let's start with question number one. So here we're to determine which of these represents y as a function of x. So recall that a function, whenever we put in one input value, we get at most one output value. X equals -3 is simply a line that is vertical at x equals -3. And we can see that this definitely fails the vertical line test. Here we have x equals -4y squared. So if we wanted to solve for y, our first step would be to get the y squared by itself. Now, when we take the square root of both sides, what we're going to end up getting is plus or minus radical x over 4. So that's not a function. Looking at D, it's going to be a vertical line just like A was. That's not a function, which leaves us to the answer of C. Now, no matter what value I pick for x, I'm only going to get one y value. So for number 2, we have some relations that are written as a set of ordered pairs. So once again, one number in, one number out. So we look at A, we have no repeating x values. So this is a function of x. The reason B is not a function is because the input of -6 has two different outputs, -5 and 0. Then for the relation on C, we see that -2, an input of -2 has outputs of 0 and -6. Now, D is not a function is because it's just a set of numbers. So it's not D. For number 3, we're just supposed to evaluate the function, in this case, when x is -1/6. So 6 times -6 squared minus radical -4 times -6. And of course I made an error. What did I do here? Oh, I used the minus of the negative. Looks like I made another error. This is wonderful. Did it again. So there we go. -4 times -6. And our answer is about 211.101, which matches with A. For number 4, we were given a function, and we wanted to find g of n-3. So as you can see from these responses here, it's not going to be a number. So wherever we see x, we're going to plug in n-3. Now, as you can see, it doesn't match into the answers A through D. The reason is that we need to simplify the expression. So first, let's go ahead and FOIL n-3 squared. So n times n is n squared minus 3n minus 3n, and then -3 times -3 is +9. So for the top, this part right here is n squared minus 6n plus 9. Then we've got -6 all over 2n minus 6. I just used the distributive property here. Combining the like terms, I get n squared minus 6n plus 3 divided by 2n minus 6, and we see that as response A. Number 5. This is what we call a piecewise function. Which expression we use to evaluate depends on our input or x value. So for a, we have f of negative 4. So our first step is to determine which of these expressions we're going to use. Well, x isn't greater than negative 4, so we're not going to use the top one. But x is less than or equal to negative 4. So wherever we see x in the bottom expression, we're going to plug in negative 4. So we'll go ahead and evaluate that. And we get negative 104. Part B, we're looking for f of 0. So I look, and I'm going to use looks like the top one, because 0 is greater than negative 4. So negative 1/3, let me rewrite that. Negative 1/3 times 0 is simply 0. For C, we have f of 2. Well, once again, we're going to use the top expression because 2 is greater than negative 4. Negative 1/3 times 2 is negative 2/3. And then for the last one, D, we need to evaluate f of negative 4.4. This time we're going to use the bottom equation because negative 4 is less than negative 4. So we get negative 8 minus 6 times negative 4.4 squared. And the answer I get is negative 124 and 1600ths. Number 6, find the domain of the function. So far in this class, when looking at domain, we're looking for two things: even radicals and denominators that could equal 0. We have no radical expressions here, so nothing to worry about there. But we do have a denominator, and we know that when the denominator is equal to 0, the function is undefined. So whatever value or values make the denominator 0 will not be in the domain of our function. So we've got a simple quadratic, which we can factor. We're looking for two numbers that multiply to 3 and add up to 4. And as you can probably figure out, we get 3 and 1. So setting each factor equal to 0, our solutions are negative 3 and negative 1. These values make the denominator 0, so they are not in the domain. So the answer is all real numbers except for x equals negative 1 and negative 3. Number 7, we do have a radical, and even radicals affect our domain. We know that the quantity inside the even radical must be greater than or equal to 0. So we just simply solve for x. Now, at this point, we're going to divide both sides by negative 5. And when we do that, we're going to have to flip the inequality sign. So we get x is less than or equal to negative 2/5. And it looks like the answer is B. Okay, for number 8, once again, we're finding the domain. Now we've got two things going on here that could affect the domain. The radical on the top and a denominator that could equal 0. So I know that what's inside the even radical must be greater than or equal to 0. So x is greater than or equal to 5. Now, the denominator may make holes in this domain. So I'm going to go ahead and set the denominator equal to 0. Remember that our solutions are not in the domain. So factoring, we need to find two numbers that multiply to 7 and add up to negative 8. And we get negative 7 and negative 1. So we'll solve those equations, and we get 7 and 1. So we know 7 and 1 are not in the domain of our function. We also know that x must be greater than or equal to 5. So when we try to graph the domain, which may be helpful in visualizing, at 5, we're going to have a closed circle, and then we're okay until we hit 7, in which case it's not defined at 7. So there's going to be a hole at 7, but then any number after 7 is part of the domain. So I'm going to show you two ways to write this. We could write it as the union of those two intervals, or it can just say from 5 to infinity except x equals 7. And that concludes part 1 of the video. We'll start with problem number 9 in the next section.